In the following example, we're asked to find the area of the regions bounded by the curve y equal root x plus 1 and y equals 1 minus x. First, after sketching, we can label our points of intersection. So the point up here is 1, 1. Back here we have negative 1, 0. And over here we have 1, 0. So we need to now put in a representative rectangle. So we'll start this time by showing a dx rectangle. So here's a dx rectangle. Let's move it through the region, and hopefully now we're starting to recognize what's going to work and what's not. So here, the top is on the line, or the curve root x plus 1, and its bottom is on the x-axis until we reach this point, where it changes to the top being the line 1 minus x and the bottom remaining on the x-axis. As soon as we see a change in the curve on top or on bottom of the rectangle, that means a new integral needed to calculate the entire area. So let's try a dy rectangle to see if perhaps we can do it with a single integral for the area. So here's a dy rectangle. We can take that rectangle and move it up. The bottom is on the line 1 minus x. The top is on the curve root x plus 1. And that remains true from the bottom up to the top. So the whole way through the region, the top and bottom remain consistent. That means a single integral with respect to dy can represent the area. So the area then is going to be the integral. Now remember, you're choosing y values. You need y variables because it's dy. So from 0 to 1 are our y values. Now it's dy. So we need x as a function of y, which means both of these need to be rewritten. Squaring both sides here and solving for x tells us here that x is going to be y squared minus 1 for this one. That's our left-hand curve. Our right-hand curve, we simply move the x and move the y and find out that x is equal to 1 minus y. So our right-hand curve, 1 minus y, minus our left-hand curve, y squared minus 1. Notice the importance of the brackets here. When we open this bracket, the minus has to be distributed. So simplifying before we integrate then, we get from 0 to 1. 1 minus minus 1 means plus 1, so this is actually 2 minus y squared dy, and now we can integrate. So 2y minus y squared over 2 minus y cubed over 3 evaluated from 0 to 1. So plugging in 1 then, we get 2 minus 1 over 2 minus 1 over 3 minus, putting in 0 gives us 0, 0, 0, so 0. So we end up with 2 minus a half minus a third, which gives us 1 and 1/6, or 7 over 6 units squared.